Hello, my name is Muhammad Mukadim bin Muhammad Said. My matrix number is 73078. Today I'm going to present the work question 30 for solid 1 KNJ1083. So first of all, we have to read the question very carefully and bring out all the information that are given in this question. So first of all, that we are seen in this question is the length of the post B, also the length of the post A and C. Together, what are the question want us to deliver, which is the the stress for each of the posts. And the posts are made of aluminum and have a cross sectional of area of 400 millimeter cube. Also, if the modulus yang of 70 gigapascal is given, it is given in the book, in the notes. Okay, so before we start answering the question, first of all, as I told earlier, bring out all the information in the question so that we will not headache. Always looking at the question, what are the information that have been given. So the length of A and C is the same. The length of the B is slightly shorter. The cross-sectional area, we don't have to use the pi d square because it's already give the millimeter cube. For me, this is the way that I am understanding. If the area need to use the pi d square over 4, or it is already given directly. So for me, when the question is given millimeter square, it is clearly saying that is already the cross section area, and the modulus yang for the aluminum is the E is equal to 70 gigapascal. Next is to uh, to redraw the graph, and from the graph make it to free body diagram so that we have a very clear view of the graph. Okay, after that, the first thing that we do after all the information we already give, we have to see it individually. As I did here is the post A or C, it is the same because A and C, as in the equation, it is the same. So in this question, I will use the PA because the displacement is here. We are not going to find the displacement because the displacement are there. So we are using the PA from the displacement formula. We left the PA and bring in the AE, also L. So we get PA equal to displacement A times by area, the modulus yang over the length. So in the B, because of the B is slightly shorter, the displacement is going to be displacement A here divided by the difference of A and C to B, which is 125 minus 224.7. You will get 0.3 millimeter. So the PB is equal to displacement A minus 0.3 millimeter times the area times modulus yang and divide with the length. So in order to find the displacement first, because we have two unknown here, which is the PB, PA, and also the displacement. So we are going to use the PA so that it will be easier for us later on to find this stress. Okay, from the FBD, or we call it symmetrically, or as there is another way by using equilibrium in vertical direction. I tried to do it in the other way, but I have failed to do so. So I do the different way here. So so I assume that PA is equal to PC. PA is equal to PC, so I will assume PA and PC will be the PA. So 2, I forgot to put A here. So 2PA plus PB is equal to 160 kilonewton. It is actually 2PA plus PB minus 160 because it's going downwards. The other 3 is going to upwards. But then we move the 160 to the right side, it will be positive. So the PA here, as we have did in this post A or C and also the post B here, put all this information into the formula here in the mathematical, and we will get the displacement A, which is 328.1 times 10 to the negative 6. So as we already have the displacement A, we are left with one unknown, which we need to use it. So by using the same call it formula lah, by the same formula, I put the let's put the displacement A into the formula like this one, and we get the answer of 75.7 times 10 power of 3. So the formula for stress is equal to E over A. So we have the information. The area here, just put it inside, and we will have the 189.55 times 10 to the power of 6 Newton per meter square. But the Newton per meter square, we can change it into Pascal because Newton per meter square is equal to Pascal, and times 10 times 10 to the power of 6 is equal to mega. It will be megapascal. We will not find for the PC because the PC, as I mentioned earlier, PA is equal to PC, and the PA and PC is, we assume, as PA. Towards the PB, there's a little bit of difference because it have some of the it shorter than the post A or C. So still using the same displacement, but it will minus with 0.3. And the mathematical as usual, and we will have the answer here. And by entering the stress formula, we'll have also the answer for stress at B is 21.34 times 10 to the power 6 meters square, or in other words, megapascal. That's all for me. Thank you.